Okay, everybody. Incidentally, I forgot to I just started recording. So for those people who are just entering, watching the recording, we were discussing what the path of a point on a circle that's rolling to the right is. And it ended up looking something like this. It was called a cycloid. Then we looked at this unusual curve where the circle was moving to the right, floating to the right, while a point on it was moving counterclockwise. So we took the basic equation of a point moving around counterclockwise, but we had to add on to the x equation 12 times t over 360. That's because it was given that p, if the circle moves to the right 1 unit for every 30 degrees, so that means it moves 12 units altogether, and 12 times t over 360 will accomplish that. When t is 0, it won't have moved at all, and when t is 360, the center will have moved 12 units. And then we got to this new question. And let me take a look at the comments and see what people think. Well, a good way to start this question is to say, what if the center wasn't moving? What if the circle stayed with center at 0, 5 the whole time? And if that happened, it would be 5 cosine parentheses negative t plus 270 and 5 sine parentheses negative t plus 270. Now I see there from z, the y value is plus 5. The center always has a y coordinate of 5. But how about the x coordinate? Because that's going to depend on t. How are we going to get it so when t is 0, this, what comes after this plus will equal 20. Sorry, will equal 0. But when t is 360, that thing will become 20. And I see there from Willis, 20 times t over 360. And that's the answer to this question. Basically, there are two things happening. The stuff after the plus sign is the equation of the path of the center. This line segment, the path that just the center itself takes, is 20t over 360 for x and 5 for y. It stays at 5. Whereas this thing is the point on the circle in relation to whatever the center happens to be. It is pretty confusing how we can just kind of add these two things together, but it does work. 270, because 0 would put the first point over here, but since this is starting at the very bottom, we can add 90, 180, 270 in order to get, you could also put minus 90 instead of 270. So if you didn't have the 270, you would get a similar curve. It's just that it would start at like a different, it would start, you know, at a different spot, like over, it would be shifted over, basically. Good question. This is the purple from the original and not the green. And the reason why that is because this circle is not rolling on the actual ground, but it's floating. And when you roll on the ground, you don't get to control how far the center goes for every degree. It gets dictated to us by physics. And that's why this happens. We're going to get to that question. For instance, if I made it not end at 20, but I just changed this 20 to something like a 40, it might look more like the other thing. But here, because we're told as one of the givens that the circle moves to the right, so that when p has completed one revolution, the center will be at at 25. So they're telling us it has to get to 20 at the end. Okay, let's move on to the third scenario. And there are only 4 scenarios today. Scenario number 3. Actually, let me bring up the Desmos. Okay, check out this one. Here, the circle is not just floating to the right, but it's floating up in the air. And here you can take a look at what's happening. The center of the circle is at 0, 5 again in the beginning. But when the circle does 1 full revolution, the center of that circle has moved to 15, 10. And here's a challenge for you. And this is a pretty hard question. There's a lot of stuff going on in it. Why don't you take a few minutes now? You can talk to your people, chat about it. What do you think the equation is? And I don't know about, the perimeter. I don't know much about these. Perimeter of these things is pretty complicated. I feel like the perimeter is not a constant, because if you go like fast enough, it will be a bigger perimeter. Okay, so I'm going to mute myself and have you chat what you think the whole equation is for this strange blue curve. A good question was just asked. I didn't say it, but I should have, because otherwise there'd be no way to know. This one is going clockwise. Okay, so I saw Willis had a pretty close answer, but there was something off about it. And Z also gave an answer that's very, oh wait, maybe Willis's was right. Hold on a second. Let me go back to Willis's. Yeah, Willis's is off, but Z's, Chelsea, that's right. That's right. Left side of the classroom, third seat. Chelsea got it. Let's take a look at what that was. So this has X and Y. And at the heart of it is something like negative t plus 270 and 5 cosine negative t, 5 sine negative t plus 270. That's like this point, it doesn't know that the center is moving. So this point with relation to the center is just doing this. But the center is moving. But it's moving in 2 ways. The x value is going from 0 to 15. And that's why we have 15 times t over 360. Now the y value is not going from 0 to 10. The y value is going from 5 to 10. And that's why it's not 10t, 10 times t over 360, but it's 5 plus 5 t over 360. That way, when t is 0, this thing is 5. The center, that is. So this on the right, this is basically what's going on with the center. The center's, the y value starts at 5 and increases by 5. The x value starts at 0 and increases by 15. But this is pretty confusing, but this is the right answer. You can compare this. Willis had a pretty close answer. Willis had a 5 there. Having a 10 there also would have been a pretty good guess, but the actual answer is what Chelsea put up there. And you can see now on the screen, that's what the answer is. And you could type this into your graphing calculator, and you can, you'd want to be in degree mode because I have the 270 and the 360 there, but it will graph this thing. Okay, now we are ready for the finale of today's lesson, the cycloid. So this is what happens in the real world if we have a point. This circle, just like the other ones, has a center at 0, 5. Now, because the circle's going to the right, you don't have to be told whether it's, remember Riley had asked, is it in a floating circle, you have to ask, is it clockwise or counterclockwise? But if it's a rolling circle and it's going to the right, then it must be clockwise. You don't get to choose that because it's actually rolling. And when you picture something rolling, if you take a coin out and roll it, you'll see that a point on the coin, you can imagine like the top portion of the coin, the top point. And when you go to the right, it's going to go this way. It's not as obvious that the bottom point is also going that way, but of course all the points are going the same way. So they won't tell you clockwise or counterclockwise. By saying that it's rolling to the right, that implies clockwise. Now, here comes the sort of hard question for you, because unlike before where I told you, like for every, I told you like where the center of the circle makes it to, like in 2 questions ago, the center of the circle made it to 0, 20. But in this one, I don't tell you where the center makes it. If you just have that information, and by the way, it doesn't matter how fast the wheel is rolling, because you might think, oh, it depends how fast, but no, a slow moving wheel or a fast moving wheel will produce the same curve. So we're looking at like the same question as we did over here. Not over here, but over here. But in this question, you had to be told it was going clockwise. Here we implied it. But in this question, they literally told us the coordinates of the center. Whereas in this question, they don't. So why don't you chat, what must the center of that circle be at the conclusion of one cycle? Oh, it's question mark 5. Chelsea, thank you. But what should the question mark be? That's the thing to discuss. Type in when you think you know what that question mark is. And Ellie says 10 pi. And 10 pi is the right answer. It's not the diameter, though. It's the circumference. The circumference of the circle. Why is that? Well, I imagine if you have like a hula hoop, that used to be a popular toy in the 1950s, and you were to, instead of rolling it, I cut the hula hoop, and then I like sort of keep this piece here and sort of stretch out the rest of it. And then I like let go and it kind of like snaps back into place. The circumference would be the amount that it moves. Another way to think about this is when, as it rolls, like every like point on the circle gets to sort of touch the ground. Though it's not really that obvious that it should hit it exactly the same place, but I'm telling you that a wheel will roll in such a way that after one revolution, the point that was on the bottom to get back to the same place, the wheel will have traveled 2 pi r. And that's why the answer to this question, this is 10 pi here. And that's why the equation is x equals 5 cosine negative t plus, I think I'm going to need okay, so the center goes from 0, 5 to 10 pi comma 5. And that's why the equation is x equals 5 cosine negative t, negative because it goes clockwise. We don't get to choose that. If it's rolling to the right, that point is going to go clockwise, plus 270 because we happen to be tracking the point on the bottom. I could start at a different point if I wanted to, 180, 90, 0, but I'm not. I'm telling you that I'm tracking the bottom point. And y is 5 sine negative t plus 270. That's plus 5 because the y coordinate of the center is always 5. But the x coordinate now is not 20 times t over 360, but 10 pi. And that is the cycloid. I can show you that cycloid again on here. I'll share with you these sketches also. So here it is. Here's the curve. Yeah, t over 360 is commonly used in these. You can see, I wonder if I'm able to, I don't think, am I able to make this bigger on a computer? I could. There we go. So you can see there, over here. Oh, actually, you probably can't see the mouse. But if you look at that, the red thing, it says 5 cosine negative t plus 270 plus 2 pi times 5 times t over 360, comma, 5 sine minus t plus 270. See if I can I make it even more? Even better. So you can see there, the red one, you can see the entire equation. And that is the equation of the cycloid. And someone has a comment. Yeah, about the t over 360. Yeah, pretty much, there's going to be t over 360 pretty much all the time. Now for homework, I have a couple of other configurations of this. We mentioned already the cycloid. That shape is a very important shape. It is if you take it upside down, it's the shape that would cause a like bead on a wire to get to the bottom at the fastest time. That's what's known as the Precalc problem, which is to find that shape. It's a very famous problem in calculus, and it turns out that this is the answer to it. It's also the answer to something, I don't know how to say these words, but it's also the answer to, I think, what's called the tautochrone problem, which is there a shape so that no matter where if I put 2 beads, let's say, and I release them at the same moment, they would end up at the bottom at the same time. It also accomplishes that, so like a magical curve. Studied a lot in calculus. Okay, so that's what I wanted to show you today. I will share with you all these Desmos sketches. You could also type this into your graphing calculator to see that they're right. Jonah asked about the length of the curve. I'm not sure. I'm not exactly sure about the length of a curve. Like, I feel like it's always longer. I feel like that because it's like moving. Like, if you moved it really fast, it would be like a really long curve. So I feel like it's always longer than the circumference. That's just what I think. But maybe sometimes it's shorter if it's like moving to the right slowly enough. My suspicion is that it's always longer. Okay, let me stop with the recording. Hold on.